Let's go ahead and look at how we can create fluid typography in our own custom theme. Fluid typography is a web design technique where text size adjusts smoothly and responsively based on the viewport size. This is like the width of the screen. Instead of jumping between fixed font sizes at specific breakpoints, as in traditional responsive design, fluid type scales continuously, creating a more natural and flexible reading experience across devices. Fluid typography is useful to use because it improves readability across all screen sizes. Your type is going to look great on phones, tablets, desktops, and ultra-wide screens. It also reduces the need for many media queries. It creates a more polished and professional design feel. It allows for better performance and less code compared to manually defining type at each breakpoint. Another concept you need to understand is type scale. A type scale is a system of predefined font sizes used consistently throughout a design to create a clear visual hierarchy and rhythm in your typography. A type scale is a set of font sizes based on a mathematical ratio. It's applied consistently across headings, body, and other text. It's used to create visual rhythm and hierarchy within your design. If you use type scale, it will make your text easier to read and scan. It'll give your design a consistent and more professional look. It will help users to understand what's most important on the page, and it works great across all screen sizes when combined with fluid typography. Here's an example of how type scale works. When we use type scale, we start with a base font size. This is usually the body text. The other font sizes are calculated by multiplying that base by a scale factor. We refer to this as a ratio. In this example, you can set your base font size to 1 rem, which typically is equal to 16 pixels. And in this table, I'm showing you the results if we use a scale of 1.25. I've gone ahead and defined paragraphs and H5s to use the base font size of 1 rem or 16 pixels. Each level above increases by a scale factor of 1.25. This is referred to as the major third ratio. I've also gone ahead and showed you an example of how we can scale in a negative fashion. So for my small text and captions, I can go ahead and divide 1 rem by 1.25, which will result in 0.8 rems. Another concept that we need to consider is using the clamp function. We use this in order to create fluid typography. The CSS clamp function allows us to create responsive typography by defining the clamp. We use min size, the fluid size, and a max size. This will allow your text to scale between a minimum and maximum value, depending on the viewport width. How clamp works is if we use the pattern that I just explained, clamp, and then we put min rem, comma, VW or viewport width fluid, and then we have max rem. The min value ensures that the text is readable on small screens. The fluid, or VW, viewport width, this value allows it to grow with the screen width, and the max prevents it from becoming too large on very big screens. Here is how we would build a fluid type scale. As you can see, I'm setting paragraphs and H5s to use a step of 0. This is going to allow the fixed pixel size to be 16 pixels or 1 rem. If we take the first line as an example, 8.75 rems is the minimum font size. The font will never go smaller than this. 8.75 rems is about 14 pixels if the root font size is 16 pixels. The next part of the equation, 1 VW plus 0.5 rems, that's the preferred or ideal font size based on the viewport width, plus a fixed size of 0.5 rems. 1 VW means 1% of the viewport width, so the font size will grow or shrink as the window gets wider or narrower. When we add 0.5 rems, which is about 8 pixels, this shifts the baseline up so that the font size starts at a reasonable size even on very small screens. 1 rem is the maximum font size, so our font will never exceed this. And if 16 pixels is the root, then that means it will never get bigger than 16 pixels. This prevents your font from getting too small on very narrow or small viewports and from getting too large on very large screens. By using this technique, the font size adapts smoothly between two bounds rather than jumping between two fixed sizes. It will provide a better reading experience on different screen sizes, and the fixed rem part ensures readability on small screens, while the VW part makes it responsive on larger screens. We're going to go ahead and use this technique to create rules for our typography on the website. This will allow us to create responsive typography that works in a fluid manner. I've gone ahead and added some example text to my sample page. I have examples of all of the default headings with their default sizes as the website currently exists. We also have paragraphs and lists, and then there's some other things that appear on this page. If I open my developer tools and make sure that toggle device toolbar is on, you can see when I resize the screen, the font sizes don't change. They will remain the same no matter what size the screen is. In order to create a better and more responsive experience, let's go ahead and modify our code so that we can use the fluid typography, which I just explained. We'll go ahead and do this by adding some custom CSS to our theme. However, before we do that, I do want to show you a good resource so that you can calculate your own fluid type scales. If you visit fluid-type-scale.com, this will bring you to the fluid type scale calculator. This allows you to plug in values and easily get the clamp code that you'll need for your CSS. The first thing you need to do is you need to come up with your base font size in pixels. You can go ahead and specify this to be any number, but I'm going to stick with 16. The screen width is going to be the screen size that you're targeting at this font size. We'll leave ours at 400, and then you can plug in a type scale ratio. I'm going to go ahead and use 1.25, which is the major third value. You can obviously change this to use any values that you want. The maximum desktop size is the maximum viewport width, so all of our font sizes in our type scale are computed as the base font size times the power of the ratio that you choose. I'm going to go ahead and specify my base font size to be 19 for my desktop. And then for the screen width, let's use 1200 pixels as that is our large screen size that we're using. For the type scale ratio, once again, you can go ahead and specify any numeric value that you want. It does need to be larger than your minimum type scale ratio, so do keep that in mind. If you delete everything in here and start to type, it's going to show you the default baseline for some of the type scales. As you can see, we were using the major third for our minimum size, and I just need to pick something that's larger than that. So I'm going to go to the next one up, which is going to be 1.333. Then you're able to place a type scale. This is going to be a comma-separated list of the names you want to use. This is not terribly important for us. We're more interested in the clamp values that are being generated for us. Our baseline step is the base font size. This is going to set the font at the small size to our 16 pixels, and then based on the size of our viewport, it's going to increase at the desktop size. It is worth mentioning that I used a value of VW, which stands for viewport width. This particular tool is going to give you a VI value. VI stands for Viewport inline. 1 VW is 1% of the width of the viewport. This includes the entire width of the viewport, regardless of your writing mode. We commonly use this in responsive designs to scale elements based on the width of the screen. However, VI stands for viewport inline size. VI is 1% of the inline size of the viewport based on the writing direction of the document. Inline means the direction the text flows, either left to right or right to left in horizontal writing. So in that case, VI is going to behave like VW, or in vertical writing, such as Japanese, VI is going to behave more like a VH. So VI is writing direction aware, which makes it more flexible for international layouts. We can use either one, but I just wanted to mention the difference. If you prefer to use VW, that's fine. It will work as long as you are working with languages that go from left to right or right to left. I'm going to go ahead and copy these values because we're going to be using these for our custom CSS. We'll go back into our code editor. I'm going to go into style.css, and this is where we've been placing styles. I can really put my CSS anywhere, but I feel like it makes the most sense to put this at the top. So I'm going to place this above my navigation, and we'll go ahead and just say fluid typography styles for our comment. And then I'll begin by creating the necessary CSS. All we need to do here is target the various heading elements that we're going to be using. We're going to set our font size, and then we're going to use the clamp function. So we'll write clamp and open our parentheses. Inside the clamp function, we'll enter the necessary values. I'll specify 2.44 rems for the minimum size of my type. I'll put a comma, and then I'm going to write 1.74 VW plus 2.01 rems. This is the middle value in our clamp function. This expression basically means that 1.74% of the viewport width. So as the browser gets narrower or wider, the value is going to change, which will allow our font to scale fluidly. The 2.01 rems is the fixed base size. So this is equal to 2.01 times the root element's font size. Essentially, this is a little bit over 32 pixels. So we're telling the browser, hey, as the screen gets wider, scale the font size based on the screen width, but also add a minimum baseline so it doesn't shrink too much. This simply is going to prevent the text from getting too small at small screen sizes. Then I'll specify 3.75 rems for the maximum size. And I'm simply going to just copy this line of code, and I'll update the values for the rest of my headings. Keep in mind that I am getting these values from the Fluid Type Scale website that I just shared with you. You can use your own values, or you can go ahead and set up different values based on the amount of scale that you want. For my last declaration, I'm going to group H5s with paragraphs. I want to use the same values on H5s and paragraphs. It's unlikely that I'll use an H5, and I know that I definitely won't be using H6, so I'm just not going to include those in my CSS, but obviously you can do whatever you need to do to ensure that this will work correctly for your needs. We're going to set the minimum size to 1 rem. The viewport size for this is going to be 0.25 vertical width. We'll add that to 0.84 rems. And then the final value is going to be 1.19 rems. I'll save this and let's check it out in the front end portion of WordPress. I'm going to refresh my page. And as you can see, all of my type increased slightly. If I resize the page, the type is going to be fluid, so it's going to shrink and grow based on the page size. If you select one of your elements, so here's my H1 heading, if we look in the computed portion, you can see that currently the font size is 55 pixels. Watch this value right here, and as I resize my page down, you can see that that heading 1 font size is going to shrink, and at some point it will just get as small as it possibly can based on our clamp. So 39.04 pixels is the smallest size, but it will grow if the screen is wider. And it stops shrinking once we get to 400. So you can see if my page is less than 400, it just stays at 39 pixels. In this way, you have the ability to make your text fully responsive. I find this to be extremely helpful as it will give the user the best experience based on their screen size.